All right, guys. So I give you this practice this morning or today in class. So I just want to go over it for those that want to do this. We do have a one question, which is a free respond on a quiz with this. So I highly suggest that you guys do graph it. So delete, erase, decrease, increase. We don't need it. Well, we do need y-intercept. All right. So let's start from the beginning. Let's see. Okay. So let's start from the beginning. So first, we're going to work out a times c. Okay, so -3 and 2. So that's 1 and 3, and 1 has to be negative to give me 2. Okay, so now I'm going to do x minus 1 and x plus 3 over x minus 1. So remember, this is a repeated factor, which is my whole. That goes away. So what's left is x plus 3 over 1. Okay, I'm going to leave it over once because I want you to see something. So I'm going to start with my whole. My whole is x minus 1 equals 0. So x equals 1. This is my first point of my whole. Okay, because I want to know where's the whole located exactly. Okay, now in class I showed you guys that how do I find a y value? I'm going to plug this one back into x plus 3. So x plus 3 over 1 equals, and instead of the x right here, I'm going to plug in this 1. So that's 1 plus 3 over 1, that's 4. So my y value, it's plugging in 1 for an x, okay? That's my y value for the whole, all right? So I'm going to erase that now very quick. If you need it, you can rewind it. All right, so this is my point where the whole exists, okay, at 1 and 4. So somewhere right here, whatever the graph is going to look like, okay? Now, remember, top, it's zeros, which is x-intercept as well, called. And bottom, it's vertical asymptote. Well, I don't have a bottom, so I don't have vertical asymptote. I do have a 0, so I'm going to take x plus 3 and equal it to 0. So x equals -3. That's where my x-intercept is. Okay? Now, horizontal asymptote. Horizontal asymptote, as you remember, is we go back to our original function and we're going to look at the exponents of the x's, meaning how many x's are on the top and how many x's are on the bottom. If there is more x's on the top over the bottom, so numerator is more than the denominator, there is no asymptote. And this is what's happening. We got 2 on the top and 1 on the bottom, so that means there is no horizontal asymptote either. Okay? None. All right? Now, if the bottom, it's more than the top, so there's more x's on the bottom than the top, so that means numerator is less than denominator, asymptote is always 0. Okay? Now, lastly, if they are the same, x squared over x squared, and let's just see, we got 2 and a 3 here. If the 2 and 2 are the same, so numerator is equal to denominator, we're going to take the numbers in the front, the coefficients. And my horizontal asymptote is going to be 2 over 3. Okay? All right. So if you need to write it down, please do so. Okay? All right. What else we got here? Okay, y-intercept. All right, so y-intercept, it's when you, y-intercept, it's always when x equals 0, correct? So whatever y-intercept we have on the y-axis, it's when x equals 0. So to find the y-intercept, what we can do is we can plug in 0 into the equation. So my equation is x squared plus 2x minus 3. So that's 0 squared plus 2 times 0 minus 3 over 0 minus 1. So on the bottom, I get -1. On the top, I get 0, 0. So I get -3 over -1. Whoops, -3 over -1 which negative will cancel. So my y-intercept is 3. I can also use my simplified version right here, this one, and I can plug it in 0 into here, which is also 3. Okay? Now, I'm going to draw my asymptotes. So I got none. I'm sorry. My 0 sits at -3. Okay? And my y-intercept is at 3. So it looks like to me it's going to be a linear function from what I have here. So it's literally just going to look like this. That's why we don't have an asymptote, because we don't have anything here, we don't have anything here. So when I'm talking about domain and range, domain is all real numbers, or you can also say, remember the domain goes from negative to positive. So we're going to go from negative infinity to positive infinity, negative infinity from positive infinity. Okay, always negative to positive. So it goes from negative infinity to positive infinity. And a range goes up and down to from the bottom to the top. So again, from negative infinity to positive infinity, all real numbers because we do not have an asymptote. Okay. Now end behavior, on the right side, my function travels up. Okay. On the left side, when it is negative, my function travels down. All right. Next example. Oh, and I want to show you how to graph it. So I can graph this one. And again, if you forget what to do, you can kind of figure it out. You can look at your x-intercept right here at -3. You can look at your y-intercept right here at 3, okay? You can see that we don't have an asymptote because obviously, you know, the function's going all the way through. And we don't have either horizontal or asymptote. And you do have to calculate the whole, but again, domain shows you from left to right, it's all open, and from the bottom to the top, it's all open, as well as on the right side here, we are going to have positive infinity, the function travels up, and the negative side function travels down. So use Desmos as your guidance. All right, next question. All right, so we're going to do a times c here again. So -4 has to equal to 3. So that's 1 and 4, and 1 has to be negative. So we're going to do x minus 1 and x plus 4. And on the bottom, it's -8 and 2. So that's 2 and 4. And 2 has to be negative. So x minus 2 and x plus 4. So again, I'm going to look for my whole first, okay, and simplify it to x minus 1 and x minus 2. So I'm going to start with my whole, okay? So I know that my whole is x plus 4. So x plus 4 equal to 0. It's going to give me x equals -4. That's the first point of my whole. I'm going to take this -4. I'm going to plug it into my simplified version here. So -4, and instead of the x, -1 over -4 minus 2. So that's going to be -5 over -6. So 5 over 6. So 5, right? Yeah, 5 over 6 is my y value, because this is y equals, okay? F of x means y equals, okay? So that's my whole. You take the repeated factor, you equal it to 0, and then you plug it into the simplified version, okay? All right. Now, we know that on the top, we got zeros, and we know that on the bottom, we got vertical asymptote. So zeros are at 1, and vertical asymptote is at 2, okay? So x equals 1, and vertical asymptote is x equals 2, okay? Now, for horizontal asymptote, remember that we are using the 2 and the 2 on the tops are the same, so 1 and 1 over. So my horizontal asymptote is going to be y equals 1. Okay? Now, of course, no decrease, increase. We're going to do y-intercept. So with y-intercept, again, we just plug in zeros. And instead of the x right here, because y-intercept happens when x is 0. So we're going to do 0 minus 1 over 0 minus 2. That's negative 1/2. Negatives would cancel, so that's 1/2. So my y-intercept would be at 1/2. Why? I plugged it into here. Okay, you can also plug it into the original equation here. So that's going to be, it's going to end up being 0 squared, 3 times 0. So you're going to have really negative 4 over negative 8 left, and it's going to simplify to 1/2 as well. Okay? Now, lastly, we got domain and range. So this function right here, it has some asymptotes. So let's draw them. Okay? We got a asymptote vertical at 2. Okay, and horizontal at 1. We also have a 0 at 1 right here. So that means the function is going to go something like this and like this. Okay, so domain and range, domain is x-axis, range is y-axis. So again, what I want you to remember is that it goes from negative infinity to positive, and from negative the bottom to positive. Always negative to positive. So we're going to go negative to our asymptote, which is vertical asymptote. This is where the wall stops, which is 2, and then from 2 to positive infinity to the right. Okay? Now for our range, we're going to go from the bottom to the top. Okay? So again, right here, bottom, top. So we stop at the asymptote. So we got negative infinity, stop at 1. Nope. Yes, 1. And then from 1, we continue to go to positive infinity. Okay? Here we go from the negative infinity to 2, and from 2 to positive infinity. Okay? All right, now end behavior. Okay? End behavior here. Let me rewrite this all. Okay, nice and clean. Very quick. So 2 was an asymptote. Horizontal 1 was horizontal asymptote. Okay, we had a 1 as a 0, so the function went through it, and it went here. Again, positive, negative, negative, positive. So end behavior for the function f of x means y will always go toward horizontal asymptote. So as my function is approaching positive infinity, my function is approaching my asymptote here. Okay, so it's approaching 1, horizontal asymptote. On the left side, as I am approaching negative side with my x's, my function is traveling up, and again, it's approaching my asymptote, 1. Okay, so it's always going to approach a horizontal asymptote.